Hey, it's Mr. Saltana. This video is going to explain how to do dimensional analysis. So what is dimensional analysis? It's really just a way to convert between units. It's a nice way to do that. It's convenient because it works going from different systems. So if you're going from the English system to the metric system, or you're converting currency, or really any kind of unit to any other similar unit, you can convert to using this method. It's also a method that allows you to check whether you set it up correctly. So that's also part of the reason that we do it. And when the calculations get more complicated, that becomes really important. So you want to practice this new method. But in order to have an idea of how this works, there's just two key concepts we have to have. So if you can get these two concepts, then this should be easy for you. The first one is, what is the value of A over A? So anything over itself is going to be the number 1, right? Okay. What about the value of B over B? Also 1, right? Okay. Well then what about A over B if we're told that A is equal to B? Well, that's also equal to 1, right? So that's going to be important in a minute. So as long as we know that we can say that these two things are equal to each other, one on top of the other makes it the number 1, which is going to be important. Okay. Here's the second part of what we have to be able to understand to get this. What we're looking at here is this heart times this fraction with a square over a heart times this other fraction times this other fraction, and then we have equals a lightning bolt. So if you take a minute to look at the pattern, you might spot what it is, but essentially each new fraction has the same symbol on the diagonal, right? So heart up here, heart down here, square up here, square down there. This is going to be the case every single time for these dimensional analysis problems, so that makes it really easy to kind of visualize this way. Also, because we have the same thing on top and on bottom, these are canceling each other out. So hearts have canceled out hearts, squares have canceled out squares, moons canceled out moons, and so we're left with the lightning bolt because nothing's canceling that out. So all of your problems should be set up so that you're left with the unit that you're trying to get to. Okay. So then, what if we follow the same pattern? Then what symbol should we have at the end of this? So at the end of this pattern, what symbol should we be left with? Well, same thing as before, right? So our clouds canceled clouds, suns canceled suns, the do not sign canceled the do not sign, and we're left with the orange star. Okay, last one of this type. What is the missing symbol here? So if we take a minute to look at it. So the missing symbol is another smiley face, right? So if we're left with the triangle at the end, that means that we must have had a smiley face on top and a smiley face on bottom to make them cancel. So that's how this works. So it's always going to be set up that way. You'll always have some unit, and then you'll want to put that same unit on bottom, new unit on top, same unit on bottom as that previous unit, and the pattern goes like that. Okay, so let's look at an actual problem then. So the first example we're going to try is converting 24 inches to feet. Now, I'm sure many people when watching this are going to think to themselves, obviously it's 2 feet, why do I have to follow this process? We're starting with some easier problems just to verify that the process works, but trust me, they do get more challenging, and so the process is going to be what saves you when it gets more challenging. I personally love this topic because it kind of takes the thinking out the window. Whenever I'm unsure, I just use this method to see what I'm supposed to do next. It kind of helps me out if I get stuck. If I don't do the method, I don't know for sure if I did it right, and I might just stay stuck. So let's see. So the first thing you always do is you take what you're given. So the given here is that we have 24 inches that we're trying to convert. So we're going to start with that, 24 inches. And then what we do is we're trying to convert that, right? So we multiply by a fraction. So this is going to be the case for every problem. So I'm going to put the multiplication symbol and the fraction bar. Then we have to decide what goes where. If you're following the same pattern as we did a minute ago, what units, so not what number, but what units, inches or feet, should be going down bottom here? So you probably realize that it's the same pattern, right? So whatever you had on top goes on bottom. So we've got inches. So we place the same unit that we started with on bottom. Just the units though, not numbers yet. The unit that we're trying to go to is the unit that goes on top. So put feet, or in this case, we're going to put foot on top. And then we need to look at the relationship between them. So remember before when we were talking about the A over B, as long as they're equal, we're allowed to do this? What is the relationship between feet and inches that would make feet and inches equal? So how do they relate to each other? Well, we know that there are 12 inches in 1 foot. So 12 inches equals 1 foot. So that's why we put those there. And so then we have our setup essentially. So now once we start to set it up, we can check ourselves in a couple of ways. One of the ways is that we see that our units cancel. Again, the reasons why our units cancel and why they're supposed to cancel is because we have the same thing on top as we have on bottom of our fraction. So when we actually do this multiplication, it's like this line gets dragged across, and we end up having inches on top and on bottom, and they cancel. So that's our first step to verify, did I do this correctly? Very important to do that step. The only other step you have to do to verify is to make sure that for each fraction that you had, so like this foot in inches fraction that we have, we need to make sure the top is equal to the bottom in some way. And 1 foot is equal to 12 inches. So like we said before, as long as the top and bottom are equal, then we're essentially multiplying by the number 1. So each of your fractions should be equal to the number 1. And that's why this is sort of mathematically legal, because we're not really doing a multiplication problem, a division problem. We're not changing to get to a different result. We're just converting the units. And for us to be allowed to do that and still have the same overall value, for example, 24 inches being 2 feet, in order for those to come out as equal concepts, then each fraction has to come out to the number 1. Same value on top as the value on bottom, just different units. So we know that 1 foot is equal to 12 inches. Okay, so then we cancel those out. And the last step is that we are multiplying across the top and dividing by the bottom. So 24 times 1 divided by 12. This is huge. This is not cross multiplication. That's a different concept. That's working with proportions. There would be an equal sign here if that was true. Never ever do cross multiplication for this. You take the top, 24, times the other top, 1, and then divide by the bottom parts. That's all for this. Never cross multiply. We're never going to do 24 times 12, so make sure you know to never do that. And we get 2 feet. Okay, so let's try a more complicated example now. Let's say we're going from 1 year to minutes. So you don't happen to know how many minutes are in a year, right? So I can't just slap that in as my first fraction. But what's something we do know? We can kind of work our way across. Well, we know that there's 365 days in a year, right? So then I'm going to put my 1 year on bottom because I need those to cancel. I'm going to put my 365 days on top. Okay. Now, I don't know about you, but I don't know how days relate to minutes either off the top of my head. So, but I do know about something a little bit smaller, say like how many hours there are in a day. So then I'm going to put my days on bottom because that needs to cancel, right? So whatever goes on top goes on bottom. And it has to be equal, so 1 day is equal to, on top, 24 hours. So far, so good. And I also don't know how hours, actually I do, I know how hours relate to minutes. So how do hours relate to minutes? Well, there's 60 minutes is equal to 1 hour, right? So that means of that expression, our hour has to go on bottom, and our 60 minutes goes on top. So let's verify our process. Did our units cancel? Our year and year canceled. So far, so good. Our days and days canceled, and our hours and hours canceled. So same thing on top as on bottom for each diagonal. Looking good so far. And then does what's on top of each fraction equal in some way what's on bottom of each fraction? So there's 365 days in 1 year. So that comes out to number 1. Check. 24 hours in a day. So that comes out to another number 1. Check. And there's 60 minutes in an hour. So that comes out to another number 1. Right? A over B, if they're equal, is equal to 1. So that means we are setting it up right. Everything's good. And then, so all that we do is we multiply across the whole top and divide by the bottom. So 1 times 365 times 24 times 60 is equal to 525,600 minutes. There's a whole song about this if you want to check it out. It's called Seasons of Love from Rent. Okay, so one more problem. Let's make it a little bit more life applicable as well. Okay, so here's the example. You're having a party. There's 30 people coming. You're pretty popular. 30 people coming to your party. And you want to know how many pizzas to order for this party. And the only thing you know is that each person is going to eat about 2 slices. And each pizza has about 8 slices. So maybe thinking to yourself, where am I going to multiply? Where am I going to divide here? Dimensional analysis sets this up for us so that we don't have to question what we're doing. We just set it up, which is nice. So, just like before, we start with the given, right? We're starting with 30 persons, 30 people. And we know we need to have the same units on bottom, right? So we need to have persons on bottom. And so we need to have some kind of relationship with persons and the problem. So let's see. We had that a pizza was 8 slices. That's not going to help us for this second part. And we know that a person would eat 2 slices. So that's kind of like saying one person equals 2 slices. So then I can use that relationship. Okay, so what am I going to put on bottom? On bottom, I'm going to put the one person. And on top, I'm going to put the 2 slices. Okay. Now we're almost there, right? I know I'm going to have to put slices on bottom. And I need a relationship. What's the next relationship? So there are 8 slices in one pizza. Okay, I could use that. Are the 8 slices going to go on top or bottom? Well, they have to cancel, right? So they go on bottom. And the one pizza goes on top. And then I just had to verify, did my units cancel? Well, persons on top, persons on bottom. Those canceled, check. Slices on top, slices on bottom, check. And then my one pizza is on top. So that works out. So that means we did it correctly. So then, of course, for this to solve, we would do 30 times 2 times 1. And then we would divide by the bottom, which in this case is 8. And that's how you figure out how many pizzas you would need. So you can use this for anything, to convert anything to anything. So that's it for dimensional analysis. Thanks for watching. And remember, chemistry is everywhere.